Wonderful. Thank you for the introduction. Thank you for the first presentation, David, and the Alice colleagues to set up today's seminar. Yeah, you see here, and I'll try to be really quick to look at the current challenges. You see, there's a vast background on testing and developing the various ERS technologies. My presentation will focus on catenary, the catenary solution. The other solutions are maybe at a slightly lower TRL technology readiness level. Anyway, lots of research and testing has been done. So this is how it started roughly 10 years ago on a dedicated test track with a truck-trailer combination with a simplified pantograph generation. And if we move one step or one slide further, you'll see in a very short time for technology development. Just 10 years later, we are on a public highway, full operation. That's one of the busiest highways in Germany. You see here, south of Frankfurt in Hesse, with 3 trucks with the latest pantograph design lined up in a field trial operation of about 12 kilometers in one direction, 5 in the other. So it's tested, it's road hardened, and it's ready to go. So if we look now into the key milestones and current challenges, and I ask you to move forward a little bit with the next slides. I can even go one further. Let's see. Even one more, just the key milestones, just to repeat quickly. So we've come from TRL5 demonstration pilot, 2010, 2011. We had the industrial pilot with continuous testing, intense talks and reports, interdisciplinary research into road integration, coming up finally with a sort of industrial pilot. Then we moved on. You see here 2015, 2017, the various public field trials with trucks in Sweden and California with different hybrid technologies involving also CNG and diesel hybrids. But now the focus, and I think for the future, will be mainly battery catenary or battery ERS hybrids. And yeah, you can move one further. So we see now, if we sum it up, that latest with the start of 2019 with the 3 large-scale field trials on German highways, like we have seen on one of the earlier slides. The catenary technology reached TRL level 8 with first implementations in the qualified system. In total, there were more than 30 hybrid trucks equipped to run on ERS of different brands, not just one. Calculating and taking all different installations together, it's more than 40 kilometers of overhead catenary lines have been equipped, millions of kilometers traveled, hundreds of thousands of kilometers traveled on catenary lines with a very high availability of the system, positive feedback of the drivers and operators, and no accidents and failures caused by the system or component failures. So the question I was asked today to focus on what's necessary to come to TRL level 9. So that will be the next 2 slides. So there are a number of challenges, but we'll see here. But it's doable, to quote David, and they can be overcome. Questions focusing on the overall systems performance, especially supplying a high number of trucks by dynamic charging. For logistic operations, we also see the point of construction and driving. So construction sites during normal highway operation, adjustments to the emergency and emergency response concepts, and the integration of driver assistance. And if you go one further, you'll see they are all technical concepts at hand um, that would fit to or are suitable to overcome the solutions. So an increase of the system voltage to DC 1500 volts, as it's standardized for decades in railways, is advised in the recently published European specification on ERS. We proved in the different locations that it's possible to set up the catenary lines and also the substations along highways without full blockings or full closures of the highways, so that the very short time closures can happen maybe within matter of minutes, to maybe bring in some equipment by cranes, but it's not over days or weeks full lane closures. It's a matter of minutes or quarters of hours. The emergency concepts have been heavily discussed, and there's a revised generic rescue concept developed by DLR and another German research institute. They tested with the emergency response staff, and it's feasible to organize emergency response. And of course, we are talking logistics and integration of driver systems. They are already, to a certain degree, integrated into the pantograph operation, and the dynamic charging has, as I quoted, or as I talked about earlier, has already been tested to high power levels, as indicated by David, that are necessary to really make the most benefit of the combination, or the highest benefit of the combination, to use the time on the road to charge. And that would be already my conclusion. If you go to my last slide, um, um, in terms of the topic of my little input, so the technology is ready to be implemented on a larger scale. And I would highlight really two benefits that combination of ERS with battery trucks that solution could bring. So that's the downsizing of the batteries. Various other projects showed that you could downsize battery capacity to be installed in the trucks from maybe 700 or 600 kilowatt hours to cut it roughly to half, without problems in reaching a destination. So you can significantly, for hundreds of thousands of trucks we have in Europe, cut the battery size, and not just once, but in cycles every 5 years. So that's a huge impact. And the second thing, there was further research in Germany. If we focus on stationary only charging on truck stops or on warehouses, we would need to equip, and that's rather not doable, all parking lots. And we talk about 80,000 to 100,000 parking bays or parking lots in Germany along highways. They would need to be equipped all with stationary charging of different power levels, and that's simply not feasible. So combining the technology, stationary and dynamic charging, would overcome that challenge. And with that,